Hello and welcome to lesson 3.2 over angles and parallel lines. Now, in the last lesson, 3.1, we did learn about parallel lines and then transversals intersecting lines, and we learned about angle pairs called corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. We're going to use all those same ideas again today, but we're going to look at what happens when the two lines that the transversal crosses are parallel. We get some angle relationships that work out kind of neat. So before you begin lesson 3.2, do make sure that you have kind of read through the lesson in the book and done vocabulary for this lesson in your vocab notebook. You will recall that the vocab for this lesson is all theorems and postulates. We don't have any highlighted new words, but we do have several theorems and a postulate or two that are going to be very important for us to have written down in those vocab notebooks. So if you've done all that, we should be ready to begin. All right, in the past, we've named angle pairs formed by parallel lines and transversals. Now we're going to use theorems to determine the relationships between specific pairs of angles. And we're also going to use our algebra, writing and solving equations, to find angle measurements. So let's take a look at our first postulate. It says if two parallel lines are cut by a transversal, that just means intersected by this transversal, then each pair of corresponding angles are congruent. So we have angles 1 and 3 that are congruent. We have angles 2 and 4 that are congruent. We have angles 5 and 7 which are congruent, and those will actually be the same as 1 and 3 in measure. And angles 6 and 8 are congruent. So let's take a look at example 1. In this figure, the measure of angle 11 is 51 degrees, and the measure of angle 15 is what I'm supposed to find. Well, you'll notice they are corresponding angles, so they should be the same measure because they're congruent. Since they're congruent, and other measures are equal. So this is what I want you to write down. We know that 15 is congruent to 11, and because they're congruent, their measures are equal. And then we can just substitute and say the measure of angle 15 then equals 51 degrees. Now, these are the things you have to have written down in your notes. If you would like to jot these reasons down, you're welcome to. You don't have to, though. These are the important parts to have in your notes. On some problems, I will have you write down the reasons, but on this one, we don't have to. But again, this is why we know this. This is why we know this, and this is why we know this. And so we are kind of still justifying our statements. We're not doing formal proofs necessarily, but we do need to understand those reasons. So let's take a look at part B of example 1. In this figure, again, we're told the measure of angle 11 is 51 degrees. We want to find the measure of angle 16. Well, we already know that since 11 is 51 degrees, 15 is also 51 degrees because of the first part we did. But 15 and 16 are vertical angles, so they have to have the same measure. So we should be able to say that the measure of 16 is also 51 degrees. 16 is congruent to 15, just kind of to recap what we talked about by the vertical angles theorem. And so their measures are going to be equal, but then we also know 15 is congruent to 11 by the corresponding angles theorem, or postulate, sorry. And that means that 16 is then congruent to 11 by the transitive property of congruence. So their measures are equal by definition. And that means the measure of angle 16 is 51 when we substitute. Now, you don't have to write all this out. You probably could recognize that that angle measure is 51 degrees because these two angles are vertical angles, so they're going to have the same measure. And these are corresponding angles, so they're going to have the same measure. Notice that x and y are parallel lines. That's the only way to make sure that these are all the same. In fact, every acute angle in this diagram would be 51 degrees. All right, now the corresponding angles postulate leads us to three other theorems about alternate interior angles, consecutive interior angles, and alternate exterior angles. And so, again, all of these are starting with the given that we have parallel lines. When two parallel lines are cut by a transversal, alternate interior angles are congruent. So 1 and 3 are congruent, 2 and 4 are congruent. The same kind of situation is true. I'm going to skip down to 3, alternate exterior angles. Make sure you're paying attention to the right one. Alternate exterior angles would also be congruent if the lines are parallel. But consecutive interior angles, now back to the middle, consecutive interior angles won't be congruent because you'll notice I have an obtuse angle and an acute angle. They can't be congruent. They will be supplementary. And we can go through proofs of these later, but they come from the fact that if you look at 1 and 4, those are a linear pair, so they're supplementary. But 2 is congruent to 4, so this measure plus the measure of angle 1 also has to equal 180, so 1 and 2 are supplementary. So let's take a look at example 2. We've got some floor tile pattern in this diagram representing the floor tile at Michelle's house. Now we are going to assume that all of these lines that appear parallel are in fact parallel. If you want to mark them that way, you are more than welcome to. These are parallel, and these are parallel. So just use those little arrows to mark parallel lines. They're giving you in this problem that the measure of angle 2 is 125 degrees. They want us to find the measure of angle 3 in this example. Well, you'll notice I have parallel lines that are cut by this transversal, and I get alternate interior angles 2 and 3. So I know that they have to be congruent by the alternate interior angles theorem. Angles 2 and 3 are on alternate sides of this transversal, and they're in the interior of their two intersecting lines. You can call these lines L and M if you want. You don't have to, just if you want to organize your work. Since congruent angles have the same measure, the measure of angle 3 is 125 degrees. So that's our answer. All right, let's take a look at example 3. Example 3a, we're going to use some algebra skills here. We are given that the measure of angle 5 is represented by 2x minus 10, and the measure of angle 7 is x plus 15. Now, angle 5 is this angle. Angle 7 is this angle. Because these lines are parallel, 5 and 7 have to be congruent because they're corresponding angles. And so this is what we should see. 5 and 7 are congruent, so their measures are equal. So we can start off by writing this equation. You know that these two values are equal and not supplementary. Okay, so this is what we can really start by writing. 2x minus 10 equals x plus 15. And then we just have to find the value of x. So the first thing we should do is subtract x from both sides and get x minus 10 equals 15. Then we can add 10 to both sides and get that x is 25. Now here are the reasons for what we can do in each step, but again, our problem that you can write down really kind of just includes these 3 steps, and we don't have to necessarily write all these down, but I've put them there for your benefit. Good note taking would require that you maybe do write these things down or abbreviate them just to make sure you have something accurate to look back at. Let's try part B. On part B, we are told that the measure of angle 4 is 4 times the quantity y minus 25, and the measure of angle 8 is 4y. So we first want to look at what kind of angle pair 4 and 8 actually are. Well, 4 and 8 are both exterior angles, but they're on the same side of the transversal in. Now, we don't have an angle pair that we specifically call consecutive exterior angles. We don't have that specific pair. But what we do notice is a relationship between angles 4 and 6, that 4 and 6 would have to be supplementary because they form a linear pair. 4 and 6 are a linear pair, so they're supplementary. So 6 and 8 are congruent, so I can eventually figure out that 4 is going to be supplementary to 8. And here's how we kind of arrive at that. We know 8 is congruent to 6 by the corresponding angles postulate. Then their measures are equal by definition. And I know the measure of angle 6 must then equal 4y. So I can set up that this is also an expression that is 4y by substitution. Next, the linear pair theorem tells me that if I add these two, they should equal 180 degrees. Well, that means I can substitute those values in and say that 4y plus this quantity equals 180 degrees. And this is really where we can kind of start writing things on a problem. Again, if you want to write all these in your notes, it's probably a good idea. I'm not going to require that, but if you want to be able to look at your notes later, it'd be a good idea to write those things in because it helps you understand how we arrive at the equation that these two values add up to 180 degrees. And then we just have to solve for y. I want you to go ahead and try and do that, solve for y, once we have this equation as our starting point. If you need more time, pause the video, otherwise we should get the following results. When I distribute, I get this equation, 4y plus 4y minus 100 equals 180. I can combine these like terms to get 8y and add 100 to both sides. And then if I divide both sides by 8, y is 35. So our answer should be y equals 35. If you want to check that, you can plug it back in and find out that it does give you supplementary angles for 4 and 6. All right, on example 3c, we're again talking about angles 4, but now we're going to talk about angle 5 with that. Now angle 4 and 5 here are along these two lines along transversal P. So we're kind of shifting what we talk about as the transversal. 4 and 5 then would be alternate exterior angles. So we know they'd have to be congruent since M and N are parallel. So you can go ahead and mark them congruent. That means these measures should be equal to one another. What I want you to do is to try and write an equation for this before I show you what it is. When you are ready, if you've paused the video, if you need more time, go ahead, but otherwise this is what we should get for our equation. 5x minus 12 equals 3x plus 16. All right, take a few minutes, pause the video, and solve that equation for x, and then we'll check our answer. All right, if you need more time, pause the video, but this is what we should get. When I subtract 3x from both sides, I get 2x minus 12 equals 16. When I add 12 to both sides, I get 2x equals 28. And when I divide both sides by 2, I get x is 14. All right. Then we have one other thing in our notes that we want to talk about. I don't want to forget to mention this theorem, but we do have what's called the perpendicular transversal theorem, and it says this. In a plane, if a line is perpendicular to one of two parallel lines, it's perpendicular to the other one also. And so this comes from our corresponding angles postulate. If I know this is a 90-degree angle, these corresponding angles are congruent then. So this is also a 90-degree angle. That means the transversal is perpendicular to both of the parallel lines. All right, we'll do some examples that might use this, so don't forget about this theorem, but that does conclude the examples we have in our notes. Remember, we do want to come up with some questions that you might have over this lesson, and I want you to write those questions. Think of 2 or more questions about this lesson. And then I want you to write those in your vocab notebook. As your summary questions for lesson 3.2. And we will use these questions in class, but I do want you to have those written down in your summary section for summary questions in your vocab notebook. Again, 2 or more questions that we can discuss in class.